of a population, or I want to estimate the variance of a population. See, in our central limit theorem, what we have said is probably the sample mean is an estimator to the population mean, and it's a normal distribution with variance equal to sigma squared by n kind of stuff. Now, when I have to do any estimation, given some data, let's say a raw data is given, that too not 30 plus elements or something, where I can directly use the central limit theorem and all. If at all I just have around 10 data points, and at the same time I have an idea about the distribution which that particular values can follow. Based on that, I can try to estimate the mean or the variance by looking at the sample observations. So from that standpoint, we have two different modes of estimation. One is a point where we are estimating only one value, whereas the other one is an interval. The next chapter deals with an interval based estimation, which is a confidence interval estimation. Whereas initially when I start off with the point estimation, it is more to estimate one value, a pointed value to a particular parameter. So there are again 2-3 methods to estimate that, right? So finding a single number estimate to a parameter value is what is our intention. So we will talk about the two major methods to do that. One is called as the method of movements. Movements are nothing but finding out the mean, the variance from the skewness and all from the data. They are all the typical movements. So we are using that method of movement to estimate the unknown parameters. And the second one is the method of maximum likelihood. We use the concept of differentiation heavily here to estimate the parameter based on the maximum likelihood. Probably the better and effective way of estimating the parameter is the maximum likelihood kind of estimation. Even it has a lot of applications in the real world also, and probably from your exam standpoint also, the questions can very comfortably be expected on the maximum likelihood based estimation. Now, what do we say when we have to talk about the method of movements? It is nothing but, see here, these kind of things are applicable for estimating parameters. See, in every distribution there are some parameters, right? For example, in a binomial distribution we have n, p, some values which are to be known, right? In our Poisson distribution there is a lambda. In exponential distribution again there is a lambda. So each of the distribution, and in gamma distribution there are two, alpha and lambda. So these are what we are calling as parameters. And how do I estimate these parameters from the data? Right? Because at the end, if I have to associate that this will follow a normal distribution or this will follow an exponential distribution, unless I know those parameters, it's not easy for me to draw a probability distribution or find out the integrations or find out the areas or whatever are there. So from that standpoint, this method of movements is typically being used. In this case, if it is a method of movements kind of a estimation, the process is very simple. You find out the sample moment and solve it for the parameters of the population. It's as good as, let's say, if the question is like this: a random sample from an exponential distribution. So these are the values of exponential distribution, right? Some probably you have the intention that the claims follow an exponential distribution or something like that. So let's say these are the values which are generated out of the exponential distribution. Based on this, We know that the exponential distribution has a parameter, has a probability function of lambda e power minus lambda x. So if at all the values are like this, he is asking us to find out the value of lambda. What could be the value of lambda if the sample observations are more like this? So in these cases, few things we can understand is, for an exponential distribution, the sample mean, the mean is actually equal to 1 by lambda. For an exponential distribution, the mean is 1 by lambda. So what I can do, I can find the mean of these values and equate it to 1 by lambda. That is what is the method of moments estimate, which is you find out the mean of the sample. You know the mean of the exponential distribution, what is the formula? Equate the two, and from that you obtain the value of your lambda. So it is more like, now if the numbers for us, (14.84, 0.89, 11.75, 1.18, 2.44 and 0.53. I think 0.19, right? Okay. So what we are saying is, let's say I have only this 6 data, right? With this 6 data, I want to fit this data into an exponential distribution. So for an exponential distribution, the only thing I need is lambda. And we also know that the mean of an exponential distribution is 1 by lambda, right? And the mean of this, I can find out the mean of this data, which is the average of this, is equal to 5.155. So 1 by lambda equal to 5.155. So based on this, I can get lambda, which comes out to this much. Lambda is 1 by 5.155, so which is 0.1939. So using this data, if I want to find out, see from here what he says, you estimate the lambda and probably use this for what is the probability that an average, the average claim is greater than 10, right? See, the way the question goes is, a sample of data will be given and asks us to estimate the parameter called lambda. Use that parameter lambda to find out the probability that average claim size, or whatever is that number, average that the number is greater than 10. So how do I use that now? Now if I get my lambda as 0.1939, or probably if I round off 0.194, that is what is the lambda we got. So if the question is greater than 10, right? So what is that we are saying? What is the probability of greater than 10? So it is nothing but 10 to infinite, right? For an exponential distribution, if the question goes extended like that, the way we are solving is lambda e power minus lambda x dx. So it is becoming lambda, the integration of e power minus lambda x is e power minus lambda x by minus lambda. This is getting integrated between infinite and 10. So minus of e power minus infinity is 0 minus e power minus 10 lambda. So the probability is coming out as e power minus 10